Alright guys, so I just wanted to make a couple quick videos today just to kind of help you figure out what's going on in regards to finding special lines of asymptotes and points of discontinuity, x-intercepts, just how to look at a rational function. So this first video is just dealing with vertical asymptotes and points of discontinuity. And what I know about a vertical asymptote is that it's an imaginary line that the graph approaches but does not cross. Like if I were to look at a vertical asymptote, it's going to go straight up and down. Okay. Another thing just to look at is the idea of a point of discontinuity. It's a location of the graph does not exist, but everything else like around it does. So like I can have a line, and then what happens is I have a big hole right in, or I have a small hole in the middle of that line, and that is called a point of discontinuity. Now, how do I find either of these two things? Well, the first thing that we're going to do is we're going to factor the numerator and also the denominator. After we do that, what we're going to try to do is try to identify the point of discontinuity. So if a numerator term and a denominator term cancel, then we're going to set each term equal to 0, and we'll walk through an example like that. And then after we identify our point of discontinuity, we're going to set the term in the denominator that did not cancel equal to 0. So let's look at it like an example, and we have all of our directions right here. All right, let's just try to figure out. Okay, so we're going to factor out the numerator and denominator. That is done because it's already factored out. The next thing that we're going to do is identify the point of discontinuity. If a numerator term and a denominator term cancel, well, we don't have anything like that, so we don't have to worry about this. Okay, so now, just to find the vertical asymptote, we're going to set our denominator equal to x minus 5 equal to 0, and then we're just going to solve for x. So I would get x equals 5 to be my vertical asymptote. So in this case, I have a vertical asymptote at x equals 5, but I have no point of discontinuity. Okay. All right, so let's look at this next example here. All right, so I have 3x plus 3 divided by x plus 2. All right, so first thing that we got to do is try to factor out the numerator and denominator. In this case, we can factor out the numerator because 3 is the greatest common factor. So I factor out the 3. I have x plus 1 in the numerator and divided by x plus 2. So I have the factored out. Does anything cancel in the numerator or denominator? No. So we're just going to move on to this next step, in which we're going to try to find the vertical asymptote by just setting x plus 2 equal to 0, because that's the denominator, and then we're going to get x to equal negative 2. This is your vertical asymptote. Okay? And once again, in this example, we have no point of discontinuity. Okay? All right, let's look at this other example here. All right, so we have x squared minus 2x minus 15 divided by x plus 3. So the first thing that we're going to do is set the numerator and denominator equal to, or we're going to factor out the numerator and denominator. If I were to do that, and you guys could easily factor it out, you guys would find it to be x minus 5 times x plus 3 divided by x plus 3. So I factored out the numerator and the denominator. Well, denominator doesn't need to, but I got it both in factored form. Now, because there are two things that cancel each other out, I know that there is a point of discontinuity. And that point of discontinuity is going to be based off what I canceled. So in this case, I canceled the x plus 3, so I'm going to set x plus 3 equal to 0, and I get x to be negative 3. So wherever the graph happens at negative 3, there is a point of discontinuity. In this case, all right, I found that. Is there anything else in the denominator that I did not cancel? And there is nothing else because I got rid of the x plus 3. So I have no vertical asymptote. Okay? All right, let's look at this last example before you guys are going to try a few. All right, so I have x minus 3 divided by x squared minus 5x plus 6. that first step is we're going to factor out the numerator and the denominator. The numerator does not have to be factored, but I can factor out the denominator, and I get x minus 3 times x minus 2. All right, so I factored out the numerator and the denominator. Second step, is there anything that I can cancel in the numerator and the denominator? And it's x minus 3. So I am going to find my point of discontinuity, where there's a gap in the graph. And I'm going to set x minus 3 equal to 0. And at x equals 3, I have a point of discontinuity. So I got that taken care of. The last thing that I want to find is what my vertical asymptote is. And what I'm going to do is, because I still have this x minus 2, that is going to tell me what my vertical asymptote is. So I'm going to set x minus 2 equal to 0, and you would get x to equal 2. I'm going to ask you guys to try these, and when you're done with that, after you're finding out the vertical asymptote's point of discontinuity, I want you guys to look at the video. I'm going to give you the answers in the next video that deals with horizontal asymptotes.